Our moderator today for the manufacturing technologies of tomorrow, which is a great segue right in from Dr. Pedrick's work. Mike Yost, the president of MESA International, will be the moderator. He brings over 25 years of industrial, commercial, and management experience to his role as president of MESA International, which is a global nonprofit for industry. Mr. Yost has spent the past 2 years leading MESA to improve the nonprofit's ability to help manufacturers make sense out of the role of modern information technologies in their manufacturing operations. And with that, I'll ask the panel to come up.
As mentioned, my name is Mike Yost. I'm the president of MESA International. And we're going to take the next 45 minutes or so and have a conversation around exploring what smart manufacturing is. And with me today, I have three panelists. All of us are part of a coalition known as the Smart Manufacturing Leadership Coalition. And so we're really here to represent the work that's ongoing with that organization. And so just briefly, I'll introduce our panelists, then I'll introduce myself, give a little foundation of how the Smart Manufacturing Leadership Coalition defines smart manufacturing, and then we'll jump into conversations here with our panelists. So first of all, here on my right is Steve Prussia. He is the manager of Strategic Systems Office at the Jet Propulsion Laboratory, the California Institute of Technology. Steve's responsible for the development and implementation of new advanced engineering environments and design methodologies, analytics for assessing and characterizing new complex systems and technologies, and risk modeling and management capabilities supported by various sponsors at JPL, NASA, and other government agencies. He has over 30 years of experience in technology development, spacecraft design, flight system development and operation, model-based systems engineering, and project and program management at JPL, NASA headquarters, and industry. So this is Steve. Besides Steve, we have Lance Fountain. Lance is the industry principal for metals and mining industry at OSI Soft, following a 20-year career in the aluminum business with Alcoa Global Primary Metals. In his last assignment before leaving Alcoa, Lance was accountable for the global development and deployment of common best practices manufacturing applications, as well as the supporting computing infrastructure. The renewed focus and resulting strategy led to the adoption of a smart manufacturing program across the global enterprise for Alcoa. This program was based on the adoption of the PI software system from OSI as an information infrastructure to support efforts for continuous improvement, operational excellence, and ongoing business sustainability. And down on the end, far on the other end, is Mark Goodstein. Mark is an entrepreneur in residence at Idea Lab, a business incubator in Pasadena, and the co-founder of Systemix, a startup that sells systems engineering tools to manufacturing companies. Mark is an accomplished startup veteran, a startup advisor, and public speaker. He started several successful companies and a globally recognized competition to spur the market for high-mileage vehicles. Mark serves on the LA and Sync Bell Commission, a group of civic leaders for the Los Angeles Basin, supported by the Annenberg Foundation, who want the region to begin claiming its equitable share of federal, state, and foundation dollars. He also serves on the board of Innovate Pasadena, an organization whose mission is to catalyze the innovation community in Pasadena, California. Those are three panelists. I myself, as I mentioned, my name is Mike Yost. I am the president of MESA International. I'll give you just a very quick introduction who we are, and then give that definition of how the SMLC defines smart manufacturing, and then we will jump into it and talk about it as a group and interact with you as you see appropriate. As mentioned before, I represent a nonprofit industry association, and our role is to help educate the marketplace on how and why to use modern information technologies in manufacturing. A lot of the previous conversation from Dr. Pedrick and a lot of the things that we see in our daily lives show the speed with which technology is coming at us. I can tell you when MESA was founded in 1992, technology was more likely to hold us back as manufacturers as far as getting into mission-critical applications. And today, we're obviously on the opposite side of that, where technology is exploding and moving at a pace that is very difficult to keep up with. So our role within industry is to work as a global community with manufacturers, solution providers, consultants, get the community together and focus on the business value as well as the tactical ways and best practices for implementing technologies. So with regard to the SMLC itself and smart manufacturing, the SMLC is also a not-for-profit organization which has its origins with the National Science Foundation initiative that has been working for several years to establish a roadmap for using advanced process manufacturing technology in manufacturing, or what is known as smart manufacturing. And if you can see from the slide here, on the one side, there's a list of the types of partners that are there. And you'll see academia, industry associations, solution providers, manufacturers, everybody coming together with the goal of driving an industry-driven open architecture shared infrastructure, so what we call a smart manufacturing platform. And we will talk about that in a minute and throughout the course of our conversation. But the real goal behind how the SMLC defines smart manufacturing is to make real-time information available when it's needed, where it's needed, throughout the entire manufacturing ecosystem. So how do we get access to the information in the context we need it? So when defining smart manufacturing holistically, as you can see here from the slide, it's a sophisticated practice of using data-driven manufacturing intelligence. How many folks have heard the term manufacturing intelligence? Anybody have a strategy or systems in place to use manufacturing intelligence in your business? All right. Not uncommon. The goal, as we define smart, is to use, it's easy to say we should work smarter. The question is, how do we actually go about doing it? So if we can capture the data, we can capture the information that's coming out of our facilities, that's in our supply chains, how can we use that to drive a couple of things that are listed here? Deeper behavioral understanding of the processes through modeling and analysis, as was talked about previously. The ability to take action as we see things happening, as we have the infrastructure in place to understand where problems are, anticipate problems, attack those problems. New insights for innovation from a broader base of innovators, which is something I believe personally is a very big upside for what the SMLC is proposing. And then when we talk about the shared infrastructure, the ability to reuse that and have capability from all those different innovators in a way that Dr. Petrick talked about, the IT capabilities that need to be, that'll be a must in the future. The focus with the platform is to help enable that without putting all of that responsibility back on each individual manufacturer. So just to sort of plug through this, with the factory at the center, with access to that information, as we're talking about, with that infrastructure in place, it really enables the ability to do a number of things. Plant-wide optimization, an agile demand-driven supply chain, sustainable production when you have access to the information, when you have that information available to you, that gives us the ability to really solve any of the problems that we need to solve. So this is the vision that the SMLC is looking to drive, and the way that they're looking to drive it is, again, through the creation of this open platform. And we'll see here also to talk about manufacturing application store, an app store, and you see in the bottom picture the iPad, very familiar environment. People are used to buying apps, dropping them in, using them. Same sort of concept applies there, that we can have more applications working to solve more problems, but in a more integrated way. When you buy an app from Apple, you don't worry that it's going to work. You know it's going to work. You drop it in and you go. That's not the reality in manufacturing when it comes to applications from that perspective. So this is a depiction of some of the work that is going on from a technology perspective. And we're not going to get into this. Anybody wants to talk about this, we can talk about it offline afterwards. Come see the folks over at the table in the other room. We can talk a little bit deeper. But this is just some of the work that the team is diving into to provide that core infrastructure. And we'll talk about what the value of that is for you. But to go back to some of the earlier points about the need for IT savvy capabilities moving forward, by offering a platform like this, by offering it as an industry open platform, the goal is that you have less of the requirements to have all the people in your organization that are capable of knitting together things like this for your organization, and more so focus on what the business value is, focus on the processes, and then find the right way to enable the business processes through the technology that you need. So we talked about everything from the data collection layer to contextualizing the data, having internal tools, the App Store, and basically providing that internal infrastructure. And I'm going to end with this on this slide. This is from General Mills. Now, this is a slide that they provide that basically maps out what they call their ecosystem of stuff. And all of these applications that are listed here are core systems and core functions and core applications that they have within their business. And this, in my experience, is about as clean a look as you're ever going to get at somebody's hierarchy, their ecosystem, and their understanding of what they have and what they need. Most people have no idea how to get it to this point. And they are one of the primary drivers behind the SMLC. They're very active in this. They see the need to have this infrastructure platform because most of those applications are either from various different vendors or homegrown themselves. And so just to be able to support the core infrastructure, to support all of these things is significant, and it's worthwhile for them if they can get they can get out of the software business, basically. They can focus on food and their business problems. So with that, that's a high-level definition of what the SMLC is about, what smart manufacturing is defined as from our perspective. So I'm just going to pause for a second and ask my panelists if they have anything that they would care to add to my definition, anything that I glossed over too quickly.
I don't think anything necessarily to add. I would just say from just an additional perspective, and this is in our interaction with SMLC and really in the early stages, our focus really is on connecting design and manufacturing. So we think about these things in terms of life cycle. I think what's important is consideration of manufacturing in the design phase and vice versa is really what makes it smart. But I think that was reflected very well with really what you had said.
Lance, how about you? Anything you would add?
I'm going to pull this out here so you can share it. So what I would add is my background's a little different than Steve's. I came from more the manufacturing operations side. And again, I think data and smart manufacturing apply to both sides, the product side and the operations side. But the important point I would mention in addition to what you said is, smart manufacturing isn't only about technology. It's about everybody's most important asset, and that's their people. So it's about taking technology and leveraging technology with your people and letting your people drive continuous process improvement and innovation. And I think that's an important point that I would want to echo in this forum. It is about people.
The stack that you saw from General Mills cost them in the hundreds of millions of dollars to build and deploy, and it was the realization that they made that they could not possibly roll that out to their supply chain that made them want to be involved in the SMLC. In order to build an open computational platform for others to participate in and be a part of their sort of global presence of food production. I think that's a key point in driving what SMLC is trying to do in building this platform. So,
How do you see, guys, smart manufacturing be able to improve operational performance?
Probably if you've been in manufacturing for any amount of time at all, you've heard concepts like lean manufacturing, Six Sigma, continuous improvement, Deming cycle, call it what you may. And one thing all those systems, those operating systems have in common is information. So I think Deming himself made a quote, you can't manage what you don't measure. Okay, so I think information has a place in how you operate. And if you think about how information is consumed, I basically break it into three categories. We use it to drive action here and now. We use it to do analysis, and why do we do analysis? We do analysis to learn what we don't know today. And then finally, and it's important to a lot of, especially larger manufacturers, we drive reporting requirements, whether they be EPA reporting requirements or whether they be manufacturing performance reporting. We drive some form of reporting out of data. So again, data and information is very critical to all three aspects, and all three aspects are really important parts of your operating system.
So we're a federal lab, so operating performance, no, I'm teasing. The design, look, the whole thing to us is about design knowledge, really. It's nothing more than what we've been given with, with the IT revolution in general. In particular, in terms of increasing the efficiency of our operations, I'd say, really, we reduce uncertainty. So as the design now is in essence understood and flushed out deeper and broader earlier, okay, we reduce the uncertainty, or at least better, really more accurately, can characterize the uncertainty much, much earlier. And so we reduce the number of surprises. That's really what comes downstream. And at the same time, when we're doing that, we increase the agility. So in our world, our trade spaces tend to be exceptionally large. We deploy in highly uncertain environments, and so there's a premium placed on the resiliency of our designs. So our systems tend to be very broad in consideration. And this is where it's really helped us, is simply to flush this stuff out earlier, to move from point designs to large number of point designs to trade spaces and trade surfaces, be able to exercise those long before we have to cut metal and actually go into production. We have long life cycles. Our spacecraft may take 6, 7, 8 years to design, 3 or 4 more years to build, and sometimes they can take 10 or 12 years to actually reach their destination. So we're dealing with very long life cycles, and this makes a huge impact then over that amount of time, really, for our kind of designs.
How about implications in the supply chain, like folks you work with in in the supply chain or in the supply chain in general? Obviously we talk about General Mills are a huge organization. Not everybody's a huge organization, right?
Right. So that I'd have to say at this point is unrealized. What we can see or what we hope to see, and the reason we've invested in this and we think it's real, is to begin to drill that down to the suppliers. It doesn't exist yet. And so the day when the 50-person shop, we talked about earlier, is in essence delivering their designs in the same way that we construct them, that is in model-based form, with the kind of characteristics that we need, with the IP embedded in those, up the supply chain, and then delivering parts as a result of that. We don't have that yet, but we're working towards that. The acquisition system, as much as anything else, has got to change for that to happen, but we see those changes occurring. And so the idea, or the time when our systems are flushed out in virtual space, if you will, and then the final physical article delivered as a validation of that model, it's coming, but we're not there yet. But that is the hope.
My perspective is different than big company or JPL, but I tend to see things in terms of the, and we hear about this a lot, democratization, the maker community, the 3D printers we've heard a lot about today already. There are, the implications of this platform are to free individuals or companies with expertise to be able to build these models that can then be adopted by other companies to do things. So engineers working at chemical plants for 20 or 30 years can now go off on their own with their own knowledge of computational fluid dynamics, build their own algorithms, their own models, sell them in the app store that was mentioned in the previous slides, and be in business for themselves, right? And there are a lot of problems with that. No company is going to take a model off the App Store unless it's been certified, in which case no one will lose their job for having adopted that model. So there has to be some way of certifying that the model does what it says it will do and so forth. But that's the sort of beginnings of a very exciting marketplace for small companies, small individuals, people to leave, et cetera. So this is really sort of a bottoms-up set of disruptions that we're seeing happening already and that will continue to roll as we move forward.
Yeah, and that really takes us into the next point about the innovation. And from my perspective, I've been in the manufacturing software space for the last 15 years. As as we were talking about with General Mills, one of my first jobs when I worked for one of the large software companies in this space was to go work with General Motors as they tried to give us back the software apps that they had built internally and get themselves out of the software game. And so the reality is that manufacturing plants have dozens, if not hundreds, of applications inside of their facilities. Oftentimes, they're bought by different departments, typically to solve different problems. They come with their own infrastructure. They may have their own databases, their own data collection, their own communications needs, and then people try to stitch those all together. And I think from an innovation perspective, what I see and what I see as being most compelling and exciting about this is exactly what Mark was talking about, in that when the infrastructure piece is taken care of and you can focus on the business problem, the domain expertise, we can put people into business. Not that they necessarily will all go into business and start selling software in this space, but that's how pretty much every company that I've worked with has gotten started. Somebody with domain expertise and guts hung a shingle and started to write their own software, do their own thing, and take it out into the marketplace. The problem is it's not scalable, it's not repeatable, and unfortunately, that's where a lot of manufacturers are stuck. You got one person or a group of people that are cobbling things together in Excel or patchworking something together. And so when the infrastructure is there already and they can focus on using the tools that are already there, they can find a model that works for them, or they can find an app and see if it works and test it out. I think we'll see a lot of innovation come from the marketplace that this kind of a platform will enable.
Whose job is it to innovate? I think there's been kind of this understanding over the years. Certain people innovated and certain people didn't. But the key is, you want to get data in front of the right people. People are your most important asset. And again, it might be a process engineer that innovates. It might be an operator. But today, that's not what we expect of them. Okay? Everybody has a siloed role. As a process engineer, maybe your day-to-day job is to go and collect data. Okay? So again, I think we have to change our whole mindset. Think about back to that operating system. If we make information consumable to everybody, if people that do the job every day can look at that data and leverage that data to improve the operation, whether they're an engineer, whether they're an operator, then they become innovators. And I think one of the biggest challenges we have is how do we broaden that base of innovators? Let's stop calling an innovator somebody that sits in a lab somewhere and does product development. Innovation means a lot more than that. I think we have to broaden our horizon and our definition.
A lot said about intelligent manufacturing, smart manufacturing, model-based design. Look, this to us is the real payoff. It's not even in improving operational efficiency. It's really there's been such a focus on ideation over the last half dozen or more years, really. And so now all of us have a floor filled with ideas off the drawing boards. This gives us an opportunity now to really broaden and exercise the ideas much more quickly. So to us, this is all about agility. It's about being able to take an idea and making them different ideas and making them consistent, to access a much broader community for ideas outside of our own lab or even out of the government, and to be able to test those objectively and efficiently in a larger system context. So the idea of whether a model is represented in an app or an idea in an app or something like that, we now can string them together and we can exercise them in a trade space way faster, much better, much deeper, much quicker. This is the real payoff to us, is better design knowledge earlier, better agility, and I think this is really where it's going to play out. I mean, it gets back to Irene's discussion earlier about, in fact, combining. On one side was the increased ability to do simulation. We are clearly in that game, but combining it with this single person, a capability of one person in a garage now to develop these ideas and inject them somewhere other than their garage. And this is the exciting part to us, really, and I think this is where it's going to pay off.
Person in the garage who's designing something with Inventor or something like that ought to be able to do the mechanical engineering, the design, et cetera, the surface, the geometry, and should be able to find out very easily, and this is being done to a certain extent in some places, where they can make that thing. So do they want 1? Do they want 10, 1,000? There should be options and direct contact to manufacturers in the area that can be their fab. at whatever stage they are. But they should also have the ability to get information that is not part of their expertise, so electrical and thermal and marketing and so forth. And again, some of that is being done to a certain extent, but not in any kind of integrated way. And again, since we're talking about this open platform, the idea of this platform is to allow for that exactly.
So let's talk about some of the roadblocks, some of the challenges that you guys see in realizing this.
I think the biggest problem is data. Everybody knows to make better decisions, to improve operations, to innovate, it starts with data. But if you look at traditionally how we've operated, data is always an afterthought. And, you know, I've got examples that I won't get into detail on, but people go out and part of their job is to collect data. You know, when you're doing advanced analysis, I had one particular story where we had an engineer out collecting data for 6 weeks before he could do the 1-week analysis. And think about that. You know, that's not really an effective process. So in my mind, it's about providing a foundation, and that foundation is information, building a model, a production model, a business model, a process model that really outlines the critical data and allows everybody to access it and consume it. Today, when we want that data, it's an exercise to go and get it. It might be in a process control system, it might be on the web, and here we are, we're going searching for it, and it becomes an exercise in and of itself to go get the data.
Well,
what we need is that data readily available.
It may be in systems that today don't have any capability to talk, right? And so that's one of the things that we're seeing with the technology as well, right? As we talk about the Internet of Things and all these capabilities in these smart devices and things, that now we're getting to a point where we can buy equipment or we can buy machinery that actually takes away some of that infrastructure requirement and now starts producing data that we can capture.
Yeah,
and do what you're talking about.
two key points there. One is, do we have instrumentation to give us the data? That's one. The second key point is, even if we do, what are we doing to collect it, and what are we doing to give that data context? And I think a lot of times that's a piece that's missing, even if we have instrumentation out there to collect the data.
Just to build on top of this, if you're an example of data collection are sensors in smart machines that do milling. Smart machines are outfitted with tons of sensors these days, and they're collecting gigabytes of data at a particular facility. This is a problem for the owners of those facilities. They don't know what to do with it. But if this is a company in a supply chain and they are making stuff, and those sensors can be used to determine whether the stuff they're making is within constraints of quality, you know, the last thing they want to do is ship product into the supply chain that is defective in any way. For a big company like a GM that makes supply chain decisions on a daily, sub-daily basis at every plant, if they were to know that widgets coming off the line, two steps down the supply chain were defective and be able to stop those boxes from even entering the supply chain, that would be a big deal for all parties involved. And the platform ought to be able to make that available. And moreover, the algorithms used to determine whether these parts are defective or not should be able to be swapped in and out by new people writing better algorithms to make use of that data. That data, in order to allow for those people to develop those algorithms, needs to be available so that people on the bench can be developing and testing against real-world data. So the data exists. It's much more of a collaborative issue that needs to be resolved, how the data is stored, where it is, et cetera. But it's happening.
I really don't think this is a $100 million problem. You know, we talk about what it takes to get it done. I think, you know, today's technology, you know, it shouldn't be that magnitude of cost to give yourself an information platform, an information foundation to use for innovation, decision making. So, I mean, that's something we all need to think about.
I think a comment on what it's not, and some had noted the educational question. From our perspective, I got to tell you, we don't need necessarily better trained graduates. All right, we'll train them. What we need are processes in place in our domain that actually take advantage of the modeling skills that you guys give us, when, or at least those of you that are educators. So it's really, the game has got to change on the making side of things. We have an antiquated acquisition system, particularly in government, that has got to change or go away. We need to be able to request these things be made for us in a way, in this particular way, rather than specifying a 4-inch document that then is returned with an 8-inch document and reviewed by 100 people. Like, I want to send a simulation environment out. I want to model back. I want to exercise it with a bunch of other models, and we want to make an award, and we want to buy something. And it's coming, and it's there in some aspects, but that has to change, I think, as much as anything else. Data is a problem. As much as the availability of it is in some cases, we're inundated with it, and trying to sort it out, particularly particularly problem we have is the integration of disparate data sets or disparate models. It's one thing to put together 2 CAD models and a thermal model. It's another thing to add, you know, cost modeling and programmatics and implementation and environmental and everything else, but you got to do it. That is the definition of the system, and we haven't perfected that yet. But again, that gets really to process.
From an organizational perspective, I think there are so many issues with organizations even knowing how to begin, and the conversations between IT and operations and different groups, and the educational piece from that perspective. There are, and I talk about this all the time when I go out with my MESA hat on, that the issues that prevent us from solving a lot of these challenges today are a lot more organizational and educational than they are technology related. But that's a huge issue, a huge challenge. And just one anecdote on that, and then we'll see if there's some questions here. Even rallying around the common definition of what smart is. If you came in here this morning and I asked you to write down what your definition of smart manufacturing is, we'd probably have a different answer from everybody in the room. And when we can't even, we have one company that was part of the SMLC from the beginning who has moved on, and smart's not good enough now. They're talking about brilliant manufacturing. So if you guys aren't prepared for smart, now you got to be prepared for brilliant as well. And that just unnerves me to no end, because we're never going to solve the problem. We're never going to stay stationary enough to fix anything or do anything. And maybe I'm just too old and I'm not innovative enough to do that. But you know, we've got to stop that kind of nonsense and actually focus on the problem. And I think the other thing that I rally the most around when I'm out talking to folks is that we need the manufacturers to be a voice in this. Oftentimes, I pull out study after study that says that the manufacturers are taking a wait-and-see attitude on where these technologies shake out, and chances are they're going to shake out somewhere that you don't like, right? So if you're not there driving the solution providers to make the technologies work the way you want them to work, you know, then you're going to end up stuck with what you get. So I think we have about 5 minutes left, and we can open it up for some questions.
Who are the solution providers? Because I'm a manufacturer and I use some of what you're already talking about, and it would be wonderful to be able to use that last piece when I get done doing an FDA on a 3D model. I'd love to be able to click a button that says, now where do I get it? But I wouldn't have any idea who to even ask to give me that button.
I'll make a comment, and I think, Steve, I'm going to turn this one over to you because it's more in your wheelhouse. But, you know, I think you can easily be misled by, if you go out and you talk to information solution providers today, everybody wants to be everything to everybody. And the reality is this: I don't know any company out there that can be everything to everybody. Again, the company I work for now, OSI Soft, we have this concept of an information infrastructure. But that information infrastructure doesn't mean we're the only tool in the toolbox. That means there are a bunch of tools you can choose from. You need to choose the ones that are best for the specific need you have at that time. And I know your need here in this specific manufacturing example, I think, is a lot more related to product design. So I'll let you kind of comment on this.
It is the $64,000 question right now. So the PLM community it has attempted to get there, but frankly, they're just not getting there. They're a little farther downstream in the life cycle. The infrastructure required to buy into a Siemens or a Dassault, CATIA-like product is just way too high, and they're not broad enough anyway. There's smaller kind of PLM-like folks that are heading that way. The answer is we don't know yet, and what's filling the market in the bottom, from the bottom up, really are open source solutions at this point. So I think it's going to play out. The question won't be who's going to be the software provider, but in fact, who's going to find a better way to integrate very quickly the highly disparate sets of these, models and model packages that are coming out. And I think that's where the answers are coming from right now. It's going to be, so in other words, what it'll look like from a standpoint of us as a buyer, for example, is I don't care how you get it to me, and I don't care the format, I don't care whatever. I mean, it's going to have to be something I can at least characterize. I'll find a way to integrate it. And right now I can tie together almost anything. I mean, I can tie Excel to almost anything, and if you can do that, you know, it's, but the Mathematica, I mean, the open source stuff is getting so good and so cheap and so fast. I think, frankly, the PLM folks, if they don't get it together in the next year or so, they're gone. But it'll be there.
Yeah, and that's part of the challenge from the SMLC's perspective is to push this forward and show the value to the solution providers to be there, to be a part of this, and to use it themselves and contribute. And so there's a lot of work to be done on that.
But at product lifecycle management, the Siemens Team Center, CATIA, PTC, they've deployed largely in defense and aerospace large infrastructures that include CAD, CAM, workflow, and so forth. It is basically the IT structure for manufacturing in places like Boeing and Lockheed Martin and so forth. So,
Yeah,
and right, automotive, so forth.
it is all about the data. You know, like you said, if you can pull your data from any source, that's really the key. You know, there are 100 tools, 1,000 tools, but it's all about the data, pulling the right data together to solve your problem.
We've seen technology being developed at Xerox PARC that does specifically what you were saying. Autodesk and 3D Systems have been doing things in this area. There are a bunch of other companies that are independent that are trying to solve that particular nut. It's active.
So thank you very much.